Hello everyone. Starting from this lesson, we will begin to operate the MCD module of NX, and the difficulty of case operations will gradually increase thereafter. The case for this lesson is one of the basic introductory cases, simulating the collection of materials transported by conveyor belts into the box at the end of the conveyor. We will cover the following topics. Learning objectives of this lesson. 1. Understand and master the use of basic commands such as rigid body, collision body, transport surface, and object source in the MCD module of NX. 2. Learn to set model physical properties and motion parameters to achieve simulation effects. Before starting the setting operation, let's first look at the simulation effect that this case aims to achieve. Based on the simulation effect, let's take a look at the specific operational steps. We will now start demonstrating the specific operational steps. Open the case model, click on the application module, and then click on More to enter the MCD module under Mechatronics Concept Designer. Next, we will set up basic mechatronic objects such as rigid bodies, collision bodies, and actuators. First, set the parts that have physical significance or can move as rigid bodies. Click on Mechanical in the menu bar and select Rigid Body. Choose Automatic for Mass Properties. The default material for the rigid body is steel, and it automatically calculates the center of mass position. In the Assembly Navigator's part list, first set the model of Material 1, which is the yellow block, as a rigid body named RB1 Material 1. Then set the model of Material 2, which is the green block, as a rigid body named RB2 Material 2. After setting moving parts as rigid bodies, since they are subject to gravity acting vertically downwards, we need to set the models that collide with each other as collision bodies. Next, in the Assembly Navigator, select these two blocks and set them as collision bodies. The collision shape of collision bodies can be set according to needs. Click on the Physics Navigator and we can see the basic physics that have been set. Then, in the model view from left to right, set the horizontal transport surface, the inner surface of the box, and the inclined surface as collision bodies respectively. Click on Collision Body, set the top surface of the model under the yellow block Material 1 as a collision body, and name it CB1 Conveyor Belt 1. Set the top surface of the vertical section of the L-shaped surface as a collision body, and name it CB2 Conveyor Belt 2. Set the top surface of the arc section of the L-shaped surface as a collision body, and name it CB3 Conveyor Belt 3. Set the top surface of the horizontal section of the L-shaped surface as a collision body, and name it CB4 Conveyor Belt 4. Then, set each of the 5 inner surfaces of the box individually as a collision body. Finally, set the inclined surface under the green block material 2 as a collision body, and name it CB10 inclined surface. In the collision body setting environment, we can influence the movement effect of objects by modifying the collision material and dynamic friction coefficient. Double-click on CB10 inclined surface in the Physics Navigator to enter the collision body setting interface. Click on the inverted triangle symbol at the bottom of the interface to see the hidden collision material options. Click on New Collision Material. Change the dynamic friction coefficient of the inclined surface from the default 0.7 to 0.9. Click OK after completing the collision material setting. Click the play button to play the simulation effect. Material 2 slides for a distance after falling on the inclined surface and then comes to rest. Click the stop button. Then double-click on CB10 collision body to enter the setting interface. Set the collision material to the default material, i.e., change the dynamic friction coefficient back to the default 0.7 and click OK. Click the play button again to play the simulation effect. After material 2 falls on the inclined surface, it accelerates down the inclined surface and slides into the material collection box. Click the stop button to complete the setting of collision bodies. Finally, set up the actuator's transport surface. Configure the conveyor belt as a transport surface to enable it to move. Click on the transport surface under the inverted triangle symbol below the position control. Set conveyor belt 1 as the transport surface, with direction along the negative y-axis, parallel velocity set to 200, named as TS1 conveyor belt 1. Set conveyor belt 2 as the transport surface, with direction along the negative y-axis, parallel velocity unchanged, named as TS2 conveyor belt 2. Set conveyor belt 3 as the transport surface. Click on the motion type to select circle. Choose the center of the arc for the center point. Median velocity set to 200. Start position set to 100. Named as CB3 conveyor belt 3. Set conveyor belt 4 as the transport surface, with direction along the positive x-axis, parallel velocity unchanged, named as CB4 conveyor belt 4. After completing the actuator settings, in order to further simulate the effect of continuous and orderly cycle of production line products, it is also necessary to set up the object source. Select Object Source under the inverted triangle symbol of rigid body. Select RB1, Material 1 as the object to copy, and other parameters are set to default. After naming is completed, click Apply. The same settings are applied to RB2 Material 2. Complete all settings for mechatronic objects. Click the play button to play the simulation effect. We can see Material 1 sliding at a constant speed along the trajectory of the left transport surface to the end of the conveyor belt, and the box completes material collection. Material 2 falls on the inclined surface and accelerates into the material collection box along the inclined surface. Both produce a new copy of materials identical to the original every 5 seconds, and slide into the material collection box in an orderly cycle. If you need to manually generate new materials or only when needed, you can modify the trigger method of the object source. Choose once each activation. Based on the settings of this task, you should have familiarized yourselves with the definitions, functions, and usage methods of the rigid body, collision body, object source commands in the mechanical toolbar, as well as the transport surface command under sensor drop-down in the electrical toolbar, and master the parameter settings and formulations involved in their usage. This is the introduction and foundation of the mechatronics concept and is essential knowledge to master. Please complete the following exercises. This lesson ends here. In the next lesson, we will continue to consolidate the use of these commands and learn new commands based on this foundation.